Today's video we're going to be talking about circuits. So we already talked about static electricity. So static electricity is electric charges stuck on an object. Maybe they move from one object to another, but for the most part they're staying right where they're at. That's what we mean by static, right? If something's static, it's not moving. When we talk about circuits, circuits are going to have electricity flowing through the circuit. So first off, if we've got electricity moving, we need to talk about conductors. So a conductor is any material that's going to allow electrons to flow. So metals are going to be typically conductors. We can have other things like liquids, especially like water if there's some salt in it. For the most part, we're going to be thinking about metals. If we take a look at a piece of wire, right? So I just got some wire right here. Well, there's metal at the end, and then we've coated it in plastic. That plastic coating there is because plastic's not a conductor, it's an insulator. So electricity flows through the metal in the wire, but the plastic insulates its surroundings, doesn't let the electricity flow through that. When we talk about circuits, we also need to talk about something called voltage. So voltage is a change in electrical potential energy between two places. Now, when we measure voltage, we talk about it in terms of volts. So voltage is volts. Once again, it's named after a dead guy. This dead guy is Alessandro Volta, an Italian scientist. He was the first person to invent a battery. So charges go from high voltages to low voltages. So what that means is we get electric current, the flow of electricity, when it goes from a high voltage to a low voltage. And anytime a conductor is hooked up to a voltage, electricity is going to flow. It just can't help itself. Just like a ball, if you put a ball at the top of a hill and you're not holding on to it, that ball is going to roll down. The charges in the battery are going to have electrical potential energy, and that's going to cause them to move through the circuit as soon as it's hooked up to a conductor. So, going on then. So, basically, oh, that was seamless. So a circuit is going to be any path from a high voltage to a low voltage that's going to carry electricity. So when we talk about a circuit, that's going to be what a circuit does. It's a path. It has to be a complete path in order for it to carry electricity. One of the things we're going to focus on a lot is drawing circuits. So if I'm drawing circuits, I'm going to use the following symbols. So first off, wires are going to be straight lines. Anytime there's a straight line without anything else going on, that's just meant to represent a wire. Now, the reason why we use these symbols is because it's complicated to draw a circuit. This is going to make it easier, and these symbols are used throughout the world in order to draw circuits. So if you went and you opened up a computer, you would see, well, if you got the blueprints for your computer, they would have circuit schematics that look something like this. Now, every circuit needs a battery, or it needs to be hooked up to an outlet. So to draw a battery, we have two parallel lines, one longer than the other, and the long side is the positive end of the battery. So when we do circuits, we have electricity flowing from the positive side to the negative side. So this is going to be where our circuit starts, or where the current starts in the circuit, and it's going to end here. We've also got resistors. Now, resistors are an electrical component that basically slows down the flow of electricity. A resistor is going to look something like this, and that's just a piece of wire with this little bit in the middle here. That little bit is made up of graphite. Graphite's just the stuff in your pencil lead, but it's not as good a conductor as the wire going into it. It resists the electricity's flow. If I have a bigger piece of graphite, it would resist it less. We'll talk about resistance more in the next time. Now, it'd be nice if I only had 3 things to draw for a circuit, but that's not the way it is. There's going to be a total of 5 things to draw. So there's a fancy type of resistor that we call light bulbs. So to draw a light bulb in a circuit, I'm going to draw basically 3 loops, and then we're going to put a circle around it. So it's meant to look like, well, it's meant to look like a light bulb, right? So inside our light bulb, we've got a little, well, we've got the bulb part is round, and then we've got the little tiny squiggle inside. That's the wire that's going to light up. So I always think these look like Hostess cupcakes, but whatever. If I have a switch in my circuit, my switch can either be open or closed. So basically it's drawn kind of like an overhead view of a door. When it's open, it's not touching. When it's closed, the 2 wires are touching. So if we wanted to put all this together and actually draw what a circuit would look like, we would start with a battery. And then I'm going to go around, and I got to connect it back over here. Now, before I get there, I'm going to start with a switch. So I'm going to put a switch on this side. And then for this circuit, as an example, I'm going to put a light bulb on this side. So I've got a battery, an open switch, and a light bulb. So this is like almost the simplest circuit we could do. What this would look like in real life is I would have a battery. So there's my battery with the positive side. And then I've got a switch here that's open. And then I've got my switch connected up to a light bulb that's currently out of the frame. Let me fix that. So now my circuit right now is open. Now when there's an open circuit, my light bulb's not lit up because an open circuit has no current. There's no current flowing through an open circuit. Let me close this switch here, and there we go. Now with the switch closed, you should see that there's a little tiny bit of light there. I kind of have to cup it because I don't have a huge battery connected up to it. The light bulb's just barely turning on. But with a closed circuit, we get current flowing. So if I open up my circuit, the light goes out, close it, the light comes back on, open, closed. Yeah, I could do that all day, but you're probably just going to skip ahead if I do. Anyways, so we can talk about a circuit being either open or closed, and that's telling me whether the switch is open or closed. If it's open, it'll allow electricity to flow through. If it's closed, if it's open, it won't allow electricity to flow through. Yeesh. Remind me to edit that out. Now, we can also describe a circuit as being either series or parallel. So a series circuit has only one path. So with a series circuit, I could have a ton of different light bulbs or resistors hooked up, but they're all going to be on the same path. Now I'm going to draw resistors because they're a little bit quicker, but if I do 1, 2, 3 resistors, so this would be a series circuit with 3 resistors. Now there's no reason why I drew them the places I drew them. I could draw all 3 along the top here, I could draw all 3 on the side, I could do 2 and 1. It doesn't matter. I just kind of spread them out evenly. Now, with a series circuit, here's the thing. If these are light bulbs tend to blow out. If this blows out, the light bulb stops working, well, that becomes an open circuit. And all of a sudden, the electricity for the rest of the circuit shuts off. So that's one of the problems with a series circuit. So series circuits are nice. Their pros are that they're easy. They're easy to make. We're just doing one thing after another, boom, 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 and that makes them cheap to make. The cons are that they break easily. So if one thing in that circuit breaks, the rest of it breaks. There's absolutely no redundancy. Everything in this circuit has to be on at the same time. Now, we wouldn't want to run our house like that, right? Because if your house was set up in a series circuit, in order to watch TV, you're going to have the blender on. And, that sounds like a pain. So, that's series circuits. Now, guess what? The opposite of only one path is a parallel circuit. In a parallel circuit, there's many paths. As many as two. Now, if I wanted to draw a parallel circuit with three different paths, or three different resistors, since I did the same thing, for series, this would be one path. There's two paths. And here's three paths. So those three different paths, this is what it would look like. Here's path number 1. Path number 2. Path number 3. So there's three different paths from the high side of the battery, the high voltage side of the battery, to the low voltage side. Now, parallel circuits have their own pros and cons. So the pros for parallel circuits is that they're more interesting. So basically, I'm never going to be able to make like a computer if it's just series circuits. I need to have parallel paths to do things that we would consider interesting with electricity. The cons are that, the pros, the other pro would be that they are redundant. They don't easily break. If one part blows out, the rest of it starts working, right? If I take away this resistor, if this resistor blows out, the other two are not even going to notice. The cons for a parallel circuit is that they're harder to make. They take more wire, they take more planning, they're a little bit harder to make, so they're not as cheap. So now what you're going to do is you're going to go and you're going to complete a little simulation on FET doing DC circuits. Have a good day.